Okay, here we go with 2-3 day 1. And your goal today is going to be to prove limits. Yes, that nasty word, prove. Okay. Because we're going to prove, we're going to need some properties of limits that we're going to use. And these proofs are not that bad, so don't panic yet. Okay, this first part of the notes is kind of obnoxious. It's all the rules. The first one you're going to be using is limit of a product. Limit of a product says if you have the limit as x approaches c of a product of two functions, that's f of x times g of x, this property allows you to break that up into the product of the separate limits. So it's the limit as x approaches c of f of x times the limit as x approaches c of g of x. So we took the limit of a product and broke it up into the product of the two separate limits. Next one is limit of a sum. And you've got the limit as x approaches c of the sum of two functions, so that's f of x plus g of x. That can be broken up into the limit as x approaches c of f of x plus the limit as x approaches c of g of x. So again, limit of a sum breaks up into the sum of the two separate limits. Next one is limit of a quotient. So we've got the limit as x approaches c of f of x divided by g of x. That can be broken up into the limit of the numerator divided by the limit of the denominator. Next is the limit of a constant times the function, which looks like the limit as x approaches c of some constant k times the function. What we can do is pull that k out in front. So it's the constant times the limit of the function. Two left. The limit of the identity function. Identity function. Which is just the limit as x approaches c of the identity function is just y equals x. So it's the function y equals x, so just x. And remember, all you're doing is plugging c in. That's equal to whatever I'm approaching c. So pay attention to this one. We started with a limit, and we're saying it's just equal to the c value because we're substituting in. So there's no limit here. And then the limit of the constant function the limit as x approaches c constant, it could be like the function, well, hold on. It's equal to whatever that constant is. So what's a constant function? Like y equals 4. That's a horizontal line where the y value is always 4. It's constantly 4. So what's the limit as I approach any x value? I'm always going to be at 4. So if you've got a constant, the limit always equals whatever that constant is. So notice these last two don't have limits on them. And that's going to be our goal when we prove, is to simplify and get things down to one of these two cases. So how does all this work? Okay, I'm going to keep this handy. Oh, I wonder. Let me see. Pull this out. Get that on there. I'm going to take a picture of that. Maybe. Let me pause. Menu. Pause. All right. Top cam. Capture. Okay, tried to figure something out, but I couldn't. I wanted to take a picture of that so I could have that up in the corner, but couldn't figure it out. So, anyway, we'll just move on. So the first one, we've got f of x equals 3x plus 5. And we are going to find the limit as x approaches 4 of f of x. Remember, limit's a y value. All I have to do is plug the 4 in here. 3 times 4 plus 5, I've got 12, 17. We could have looked at the graph or the table, but it's easy enough just to plug in. There's my limit. Now, here's the tough part of today. Prove that limit. Prove that the limit as x approaches 4 of this function is 17. And all this is just step by step. So you start out with the limit, the question, the limit as x approaches 4 of the function 3x plus 5. And our goal is to keep using these properties, breaking it apart until we can get down to the limit of just an x and the limit of a constant. So here's always on the first one. The first thing you want to do is use the limit of a sum to break this apart into two separate limits. So you have to tell yourself, tell me what you're doing. So we're going to use limit of a sum and I can now write the limit as x approaches 4 of 3x plus the limit as x approaches 4 of 5, because that's what that property says. Trying to sneak this in here. I've got the limit of two things added, which is what I've got here. I'm allowed to break that up into the limit of the first part plus the limit of the second part. That's exactly what I did. Now, again, we want to get down to either just the limit of x or the limit of k. K is any constant. Well, if you look here, I'm good to go. Limit of a constant, I can simplify this. But this one has a 3 with the x that I can't just simplify right off the bat. But what I can do is use this limit of constant times the function to pull that k out in front. So, using limit of k times f of x on this one, I'm going to go like this. That's that one. I can break that up into 3 times the limit as x approaches 4 of just x. All I do is pull the 3 out in front. This one, I'm going to use limit of the constant function, which is just whatever the constant is, 5. Now I'm ready for this one. You can forget that that 3 is there. I've got the limit of x, that is equal to whatever constant I'm approaching. So that's the identity function one. So I'm going to use the limit of identity, ID, to simplify this first term to 3 times x. Well, actually, not 3 times x, 3 times 4. I'll put the 4 in. And then this one's 5 that I'm just carrying down. So now I'm at the spot where I've gotten rid of all the limits, and now I just have the algebra. 3 times 4 is 12, plus 5 is 17. So each step down needs a property to simplify it until you get it down to the constant, then you just carry it along.